Hello and welcome back to the Fun Kids Science Midweekly. My name's Dan. I'm here with your quick bite-sized science special every single Wednesday. This week it's all about AI, space, and grass. Find out if artificial intelligence could develop emotions. We'll run through how likely you are to fall into a black hole, and when humans could live on Mars, and why grass is green.
Why can't artificial intelligence feel emotions like human beings?
So, why can't AI feel emotion like human beings? Artificial intelligence. Well, AI are machines. They have been programmed and they have been built. So they can learn everything that has been written or known by humans. That's the general idea, but they don't experience like we do. You see, we have chemicals in our body that react in ways and make us feel certain things. When it's your birthday, you might get a chemical that says, be really happy right now. When something bad happens, you might feel really sad about that. And AI, because it's all like machines at the moment, it can't do that. But what's strange is that some AI can simulate emotions. They can fake it. They can learn that, well, at this moment, I should be feeling sad, so I'll pretend to be sad. That's what the AI is thinking. They can also be trained to recognise emotions, to spot facial expressions, and maybe the sound and tone of your voice that suggests how someone is feeling. So maybe the AI might think, hang on, Dan's left eyebrow is moving upwards. He might be feeling strange and curious. I'll answer him in a way that suggests that. So that's what's going on. Chatbots, right, online, they can be programmed to detect when someone is angry or upset just by how someone is writing, and they change their answer. But at the moment, they can't properly feel emotions because they haven't experienced proper life. Opening yourself up to new experiences makes you feel and understand what emotions are and when you should feel them. And at the moment, AI can't do that. I'm not sure how long that will last, though. I don't know if you heard in the news this week, Elon Musk, who runs X and SpaceX, like big tech genius, he was warning people that AI is coming to take over. But we'll worry about that in the next few years or so. Let's move on quite quickly. Thank you so much for this question. Here is one from Noah about black holes.
Are some black holes harmless?
Well, harmless is an interesting word, Noah. Here is what scientists think happened to make a black hole. When a star dies, it collapses in on itself. It almost swallows itself whole. And stars are massive. They've got a lot of mass and matter. And that's what makes gravity. So when it collapses in on itself, it's still got that gravity. But the gravity is so strong that everything close by gets sucked into it. Not even light can escape it. It gets sucked into the middle, strung out thin like a piece of spaghetti. And that's why it's called a black hole. But we, here on Earth, are in no danger from black holes. Scientists say they're a bit like tigers. It's a bad idea to stick your head in their mouth, but you're probably not going to meet one on your way to the shops. Black holes aren't roaming around space, eating stars and planets. They're just there, where they are. And there is no black hole near our solar system, so there's really no chance of Earth ever getting sucked in while we're around. The closest black hole to Earth is 1,560 light years away from us. It would take 30 million years to get there in a rocket. So if you are right next to a black hole, it might be quite dangerous, but where you are here on planet Earth, you don't need to worry about it, Noah. Thank you for the question. And let's stay in space for this one from Ollie.
Hi Dan, how long will it be until we can live on Mars?
How long until we can live on Mars? Well, China plans to send humans to Mars in the year 2033, so in 10 years. NASA, over in America, they aim to get there by 2040, so a little bit later. Now, it takes about 9 months to reach Mars. It's about 300 million miles away. To get there, you have to wait until it's quite close to Earth in our orbit. Some scientists think different things about whether we should actually go there, because we need an atmosphere like Earth if we're going to live there. We need water, we need food, and we need to be able to make more food, right? We can't just order takeaway if we're on Mars. We need like soil, we need plants, maybe animals that will help us eat. We also need oxygen. Now, Mars is a good candidate for us to live on because the temperature isn't so different and the gravity isn't so strong. So we wouldn't be squashed by the gravity. We wouldn't be immediately scorched by the heat. So we could make the right homes. The problem is there's no oxygen up there. So we would need to make big domes or pods with air that we could actually breathe being pumped into it all the time, like something from a science fiction movie. But recently, scientists have found some ice frozen on Mars, and experts think that maybe we can use that to make water. So maybe we can move on Mars, Ollie, but not for a little while, okay? I would say we're not going to get there for over 10 years, so it'll be ages before we can live there. Last one this week, this is from Finley.
Why are plants green?
Why are plants green? Plants are green because of a chemical called chlorophyll. It sucks up sunlight. It's in their leaves. It helps them photosynthesize. That's how plants breathe, really. You know, to stay alive, we need kind of oxygen, food, water. While plants, they need carbon dioxide, sunlight, and a little bit of water too. And the chlorophyll helps them use that sunlight to make carbohydrates, which is a type of energy that they need to power themselves. It helps the plant live. Chlorophyll is what helps make the energy, and it also makes them green. That's what's amazing that happens in the autumn and the fall all around the world. Because there isn't a lot of sunlight out there, the plants can't really use the sunlight to make energy, so they don't need to make the chlorophyll to use it, which means the plants' leaves stop getting green. That's why they fall off the trees every year. And there we go. That's what chlorophyll is, Finley. Thank you so much for the question. Thank you for all your questions. If there is something you want answered, please do let me know. The best way to give us a question is to get to the website funkidslive.com and the Fun Kids Science Weekly podcast. There you can click right through. There's a big red button. Say hey, tell us your name and what you want to know. And when you're there, it's the best place to get tickets for our live show. This podcast, the greatest show in the universe. It's going all around the UK this summer. I'd love you to come along. We'll have live experiments, hopefully something from space, deadly creatures too. They will all be there on stage in front of your eyes. Find out when I am popping up near you. Come along, have a watch, say hello, get to funkidslive.com/tour. Right now, let's check in with Marina and her trusty sidekick map app. They're exploring where our electricity gets made, how it's transmitted into our homes, and they're off to the Electricity National Control Centre.
Marina Ventura, Energy Explorer.
Hi guys, Marina Ventura here. I am on a mission to explore the what, how and why behind the electricity we use and find out some cool stuff about how things are changing. Wanna come too? Excellent! The electricity we use travels across the country through a grid of cables and overhead lines, which, if all joined together, would stretch for nearly 8,000 kilometres. But who decides where and how it's sent? Let's ask MapApp. He's an electricity expert.
The electricity grid is a bit like the motorway network that helps us get around the country. There are rules and ways to ensure our car journeys are smooth and safe so we don't get traffic jams, or worse. How electricity gets around also needs to be carefully managed, and that's where something called the Electricity National Control Centre comes in. Come on, let's go inside. As you can see, there's a team of engineers who work here 24 hours a day, 7 days a week, 365 days a year.
Don't they ever get a day off?
Of course they do. Different engineers work on different days. Their role is to make sure homes and businesses have power when it's needed by taking the power from where it's generated and sending it over the grid.
But how do they know where it's needed? They don't know if I'm about to turn on a light switch or charge my mobile phone.
It's all to do with something called forecasting. Forecasting means predicting what might happen. Most of the time when we think of forecasting, we think of the weather. And that's actually one of the things that the control room will be looking at, because it affects both the demand for energy and the supply. When it's cold, we use more electricity, and when there's no wind, well, wind farms will produce less electricity for the grid.
I guess there are other ways to predict what's needed. We often use electricity in a similar pattern each day, don't we? Like switching on the radio when we wake up, and switching off the lights when it's time for bed.
Unless you're afraid of the dark, But you're right, the control centre will use models and computer programs to figure out what's needed and give instructions to the producers for more or less supply.
Electricity is also pretty dangerous stuff. I guess a big part of their job is to keep us safe.
That's right, from organising repairs to the physical parts of the grid, things like pylons, cables and substations, to ensuring that the voltage in the system is right. Voltage is like the pressure that moves the electricity around. Too much, and there might be damage to the lines. Too little, and the electricity won't be able to travel across the network. Sometimes things do just go wrong, like when it's very windy and wires are pulled down. The process of getting things back to normal is called restoration. It's a vital part of the control room's work, and one that's going to become even more important as climate change continues to affect our weather, bringing more storms and extreme temperatures.
So they have a big job. And as we change the way we generate electricity, I suppose that affects things.
It does. In the past, electricity would have come from a fairly small number of power stations that burnt fossil fuels, often close to the factories and cities which needed it.
But we're trying to reduce the amount of fossil fuels we use, right? Because it's bad for the environment.
That's right. The number of coal and gas-fired stations has reduced and are being replaced by a larger number of smaller renewable producers, such as water, solar and wind farms. These renewable sources are often located in more remote parts of the country, which can make it more fiddly to control where electricity is coming into the network and how to get it around. Control rooms are having to come up with clever ways to keep tabs on it all, and with many new locations in the mix, that's a lot of tabs.
All whilst seamlessly getting the electricity to our towns and cities.
It's a battle we are winning though, and the grid's looking to operate zero-carbon electricity network by 2025.
Amazing. Thanks, Map App. Bring on a greener future.
Marina Ventura, Energy Explorer. Find out more about National Grid and how Grid for Good is helping climate change at funkidslive.com/Marina.
If you want to find out more about Marina, get to funkidslive.com and search for Marina Ventura. And the Fun Kids Science Weekly is back with another one of our regular episodes this Saturday. This week, we'll have a look inside your brain, chatting to a neurosurgeon right before he's about to go in theatre to work on a brain. That's with Ian Kamali-Assel.
I really think I'm the luckiest person alive with the very best job. In fact, if you ask ChatGPT what's the most impressive job, neurosurgeon comes out number one, and it beats those astronauts into second place. I think all doctors have a great job making people better, but as a neurosurgeon, you're dealing with the brain and the spinal cord, and it's a remarkable structure with 86 billion nerve cells.
And we'll answer an almost impossible maths question with Thomas Woolley.
We want to convert hours to minutes. We multiply it by 60. We want to convert minutes to seconds. We multiply it by 60. And then seconds to milliseconds, that's the easy one. We multiply it by 1,000. So in the end, there are...
It's all on the way in a brand new Fun Kids Science Weekly this Saturday. I'll see you then.